Alright guys, so we're continuing this example with the ABC method, and I just want to remind you of the steps. So first step, we want to find the components of overheads. So in this example, the components of overheads is maintenance 50, shipping 100, electricity 120, and quality assurance 80. So that's the components. So every component we'll need to find a cost driver for, and we'll also need to determine whether these costs are fixed or variable. So that's step one. Then next step is consider for each component, consider the overhead is fixed or variable. So if we look at the information given, they say maintenance and quality assurance are fixed. So maintenance and quality assurance, I'm just going to highlight in green what is fixed. Maintenance, quality assurance is fixed, and electricity and shipping are variable. Now this is important because, as you'll see in the next step, that if you have variable cost, you have to divide by the total cost driver, and if you have a fixed cost, you divide by the practical cost driver. However, I just want to point out in this class example that they give you no information about practical capacity. In other words, what is the absolute practical amount that can be used. But in other questions they may give you that, but in this class example there is no practical capacity, they just give you actual. Alright, so but the next step would be find total practical capacity for a fixed cost and find actual capacity for a variable cost. Okay, so I just want to point out again that this is important because fixed costs are divided by practical and variable costs are divided by actual. However, if they don't give you practical, you can assume that practical equals actual, because actual cannot be more than practical, and if you only have actual capacity, then you can assume actual equals practical. Alright, so that would be step 4. That is step 4 and 5, but we skipped step 3. Step 3 was to find the relevant cost drivers. So this little bit paragraph told us here the machine hours, cost drivers have been identified. Machine hours is the cost driver for maintenance and electricity, and number of batches is the cost driver for shipping and quality costs. So basically you have two cost drivers, machine hours and number of batches, and they're also giving us for which component of overheads that is, and that's why we have maintenance and quality assurance is maintenance and electricity is machine hours, and shipping and quality assurance is batches. So that is step number 3 for each cost driver. Each component, identify the cost driver. Okay, then we go to step 4 and 5, and we have to, as I said again, there's no practical capacity, so we can just work on actual capacity. So if we go to each component, and that's what's done in this table here. So electricity and maintenance, they told us it's for electricity, it's driven by machine hours. Electricity is 120,000. It's a variable cost. It's driven by machine hours. We need to find the actual machine hours. And how do we find that? Well, in the question it's 10 machine hours per unit times by 900 units, that gives you 9,000, plus 20 machine hours per unit times by 300 units, that gives you 6,000. So your total machine hours is 15,000. Alright, and it would be the same 15,000 for maintenance, because both maintenance and machine hours is driven by, both maintenance and electricity are driven by machine hours, and we don't have to worry about actual versus practical here because there's no practical capacity given. However, if they gave us a practical capacity, this amount over here should have been the practical capacity amount because it's a fixed cost. So I'm just highlighting this. Just take note that this may have been a different amount. So for example, if they said that practically the practical amount of machine hours is 16,000, we would have put a 16,000 in here. But they didn't give that information, so we're assuming that what actually gets used is equal to the practical capacity. Alright, then we're going to do the same for shipping and quality assurance. That's the total, 180. And they say it's based on batches. So how do we get that? Well, a batch size is unit A is typically manufactured in batches of 20 and B is typically manufactured in batches of 5. So how do we do that? So we say, okay, well, the total would then be 900 divided by 20. So 900 divided by 20 is 45, and 300 divided by 5 is 60. So 45 plus 60 is 105. So that's where you get the 105. Alright. And quality assurance is a fixed cost. So if they told us, well, the practical number of batches is, for example, 120, we would have put the 120 in here because fixed cost is divided by practical capacity. However, in this case, again, no practical capacity, so actual capacity equals practical capacity. Alright, so once we have that, we go to our next step, which is step 6. We're going to calculate the overhead rate. So basically what that entails is we simply just take, you'll see this table's nicely laid out. We say that column divided by that column. So column 1 divided by column 2, and then we'll get 8 Rand, 333, 952, 761. And then last step is to allocate the rates to the respective products. So just have to bear in mind that this is equal to 8 Rand. It's machine hours, so it's 8 Rand per hour, right? So we're saying, well, if it's 8 Rand per hour, how many hours does unit 8 take? Well, unit 8 takes 9,000 hours. How do we get the 9,000? It is 900 times 10. Right. And so that 900 times 10 is 9,000. B, how do we get to 6,000? It is unit B takes 15 hours times 300 units. So that's 450. Sorry, it's machine hours. It's 200 hours, 20 hours per unit times 300. It is 6,000. So that would be 9,000 times 8 gives you 72,000. That's allocated to product A. 6,000 times 8 Rand is 48,000 allocated to product B. And it's the same, 9,000 and 9,000 for maintenance, but now we times by 33 Rand. 33 cents gives you 30,000 for A, and then 6,000 times 33 Rand 33 cents gives you 20,000 allocated to B for maintenance. And then shipping, based on batches, it's 952 per batch. We already calculated that product A takes 45 batches, so it will be that 45 times 952. Product B takes 60 batches, so it will be 60 times 952, which gives you that total. And then lastly, we have the quality assurance. It's 761 per batch times 45 to give you 34,286, and 60 batches times 6761 to give you the 45,714. Alright, so then the next step is, remember, we want to allocate this to a per unit cost. So this total 179,143 we take to this table, which looks a bit weird now. Just make it better. There we go. So allocated overhead product A is 179,143. Allocated overhead product B is at 178,557. 178,557. And the direct cost has not changed from the traditional method. So whether you use traditional or ABC, direct cost will remain the same. So you'll see that 180 for traditional with the same direct costs for ABC, and likewise for product B. And just a reminder, direct cost is direct labor and direct material. So once we add that total, we will get 359,143 for product A and 268,570 for product B. That's the total cost. If we want this per unit, we divide this total by that 900 and we'll get 399 per unit. And we divide this total by that 300 and we'll get 869.52 per unit. Alright, so just quickly while we're here, I want you to just notice how under the traditional method, product A was 459 per unit. However, under the ABC method, product A is 399 per unit. So you can clearly see that the traditional method used the arbitrary basis because product A is actually costing us cheaper than based on actual resource consumption than under the traditional method. And under the traditional method, product B was 689, and then under the ABC method, product B is 869. So here you can see 689 versus 869. So actually, product B is actually costing us way more than we thought. So currently, we are actually, based on the traditional method, are overcosting A, undercosting B. And now you can see from a decision-making point of view, here we overcosting a product, which means we end up selling a product to the market or pricing a product at a higher price than we need to, and people may not buy because it's priced high, so people may not buy it, but we can see it's priced incorrectly. Whereas here, we're possibly underpricing product B, and we should be pricing it higher because the cost is 869. So ABC is giving us a more accurate reflection so that we can accurately account for our costs because it's based on resource consumption and not just the arbitrary method. Alright, so I'm going to end this video here for now. That covers the calculation aspects of ABC, and it's really the crux of what you need to know. And when we come back, we'll just discuss the last few discussion points. Thanks, cheers.